we go straight into our business for today. So can you see my screen?
No, we can't see your
No,
screen.
we can't see your screen.
Okay.
We may need to stop it and start again.
Can you see it now?
Yeah, yes, I can see.
Okay. So our order of proceedings for today, that's our agenda. We'll be looking at introduction to cloud and cloud computing. We're going to be looking at the various cloud service providers. We're going to have a debate on cloud hosting and traditional hosting. We'll look at the advantages and disadvantages of cloud of traditional hosting. We're going to talk about data centers in the cloud. We're going to talk about cloud hosting and the types, which is public and private cloud. We're going to explore the benefits of cloud hosting. Then we dive into the security aspects, which is cloud security and its elements, cloud security as a shared responsibility, and actions that you as a customer can take to secure your cloud. We also talk about GCP security center tools.
I'm sorry,
So
Chibuzor, to interrupt a bit. You have another device connected. Can you reduce the volume of that device so it will stop echoing back?
okay,
Thank you.
sorry for that.
Much better now.
Yeah, okay. So what is cloud computing or what is cloud? Basically, the cloud is everywhere. If you come out of your house or your window now, you look up, you see the cloud. But we're not talking about that sense of cloud. We're actually talking about the IT part of the cloud. So basically, the cloud is an umbrella term for everywhere. The cloud is everywhere. And cloud computing basically means storing and accessing data and programs over the internet instead of a computer's hard drive. So I'm going to give you an example. Um, before cloud computing became popular, when we want to, like, let's say we want to build application, want to build an application, we do these things locally on our hard drive. Let's say we're building a website for a web application. We normally download our database servers. We have our IDEs and so on our laptops. So with the advent of cloud computing, you don't really need to have anything locally on your computer. Everything is operated for you in the cloud, and that is over the internet. So really, cloud computing has made it easier for us to go about our various applications in the workspace, in our businesses, and it is really, really taking over. So cloud computing is a form of like a new technology, and it will be good for everybody to be conversant with this. So ideally, the term cloud is a metaphor for the internet. And as I said before, cloud computing means storing and accessing data and programs over the internet instead of your computer's hard drive or your local storage. So We have some cloud service providers. In the last, we have Microsoft Azure, which is owned by Microsoft. We have Kamatera. It's not popular, but it's the cloud service providers. We have IBM Cloud, owned by IBM International Business Machines. We have Google Cloud, and we have Amazon Web Services. Out of these service providers, I know most of us into the IT sector would have heard about some of them, or we should be conversant with some of them. Personally, I'm conversant with Amazon Web Services and Google Cloud Platform. I also know that Microsoft Azure too has some very nice services or solutions that you can use their the cloud solution for. They're also very good. However, Adobe Creative Cloud and Kamatera and IBM, they are not too popular, but they also provide similar services. So depending on what you want to do, you can check out their list of services or solutions, etc. So our events, our theme for this event is centered about security and cloud hosting. So basically, what is cloud hosting? So before we dive into what cloud hosting is, what is hosting generally? When somebody says hosting, what do they mean? So hosting basically is making something available. I want make okay. Let's say I was approached by a customer to develop a website for him or web application, and after the programming process, the database process, we have finalized the process and we have tested and everything is okay. We want to make it go live. That is referred to as hosting. So if customer sees it and is okay, satisfied with it, he wants to start using it for whichever purpose he wants to use it for. Hosting is what you do. So hosting basically is deploying your application to the web, to the World Wide Web, which is the internet. Hosting is making your software, your website, your web app or files, generally data available on the World Wide Web, which is the internet. So having said that, what is cloud hosting? Cloud hosting makes applications and websites accessible using cloud resources. It is a network of connected virtual and physical cloud servers which host applications or websites, ensuring greater flexibility and scalability. So that is cloud hosting. So we cannot talk about cloud hosting without talking about the traditional hosting. Like I said before, before the advent of this cloud service or cloud computing providers, we were still hosting our websites, we were still deploying our solutions to the web. And how do we do that? That's called traditional hosting. So maybe let me say 5 to 10 years ago, we have a solution and we want to make it live. We have coded, we have tested, and we have done all that needs to be done for that particular service to be working. How do we deploy our solution? How do we do that? We go to, or we look for a web hosting provider like Rackup. I know about Rackup. So what Rackup would do is that they will ask you what you want to do. They will give you this. You give them the specification of what you have, and with that they will draw out requirements for you. Actually, it's actually your choice. So this traditional hosting of two types. You have dedicated hosting and shared hosting. So traditional hosting involves racking up servers in a data center, and this is quite costly compared to cloud hosting. So like I said before, I have an application that I want to make live. I need to deploy it on a server so it can be available to everybody on the internet. I go to a hosting company who does that for me. We can spend months back and forth on the pricing and everything. So traditional hosting types normally come in two forms. They come in as form of dedicated hosting and shared hosting. So basically, dedicated hosting is when they rack up or spin up a server for you based on what you want to do, your requirements and everything. They spin up a server, and this server will be used by only you. You get that? This dedicated hosting is the server they spin up for you is used by only you. Let's say they spin up Windows Server for you. They spin that Windows Server for you, and they upload your files there and do all necessary networking and configurations for you. That server will be used by only you, and you'll be paying maintenance costs, support costs, and all of that. So that's dedicated hosting. Well, that also have shared hosting. Shared hosting is when they add your application to a general server where other people have their applications hosted too. So let's say um, Rackup, they have a shared hosting server. They have 100 solutions on that hosting, and you come saying that you want to host your application, but you don't want to pay the cost of the dedicated server. What they do is they just create an account for you on that server and host an application there. This shared hosting is actually feasible for small applications or SMEs, but once you start having lots of traffic and users, you might want to move to dedicated hosting. So, pros and cons of shared hosting. So this is just the advantages and drawbacks of shared hosting. So the advantages of shared hosting. So shared hosting allows you to share a single server with other people that allow you to share expenses, therefore making it cheaper. So if I'm sharing a server with somebody, I am not paying the full cost. Somebody or the other people or other solutions are also paying a cost. So not all the cost is on me. It is cheaper for me. So since the limits are not exactly specified, you can use as much as you like depending on the traffic of your website. This program is ideal for small businesses that have less servers than bigger corporations. So there are no limits to shared hosting, but shared hosting is not too ideal for solutions that require a lot of resources like CPU resources, space requirements, and basically traffic. So drawbacks of shared hosting. Within shared hosting, you are most likely sharing storage servers with larger websites. This can later result in a slower processing system and loading time due to huge traffic on a single server. When you have too much traffic on a single server, it becomes overloaded and it can actually lead to downtime, and that's not quite good for businesses because customers don't like having downtime. They want everything to go smooth and stuff like that. So we talked about dedicated hosting, which is you solely having a server to yourself. So the advantage of dedicated hosting is that dedicated hosting allows you to be independent when using the storage server. Dedicated servers allow you to customize the resources and servers according to your needs from your operating system to your storage space. That's quite straightforward. And this is not to be the disadvantage of dedicated hosting. And the biggest drawback is cost of maintenance. The cost of maintenance is relatively large for dedicated hosting. So data centers in the cloud. What's the data center? Basically, a data center is a collection of servers it's a collection of network servers which network servers hosting various applications for various people. So data centers basically are like you have, like you can see in the picture, there are different server racks with different servers inside them. So anywhere you see different servers, they are actually holding information of for different people. So they can be application servers, they can be file servers, they can be web servers, and etc. So these data centers in the cloud, this has been made with a technology that we call virtualization. Virtualization allows us or allows customers to use resources. You can have two operating systems in one server. That is the work of virtualization. So all these service providers like Google Cloud Platform, AWS, they actually have these data centers, but they are virtualized. So they just give us what we want depending on what we want to use. Is that okay? So this is just like a figment of imagination. This is like a data center in the cloud. You can see the cloud in the middle. You can see the servers. Actually, they are very, very big. These data centers are very, very big. and a range of highly trained professionals are the ones that manage it in order to reduce downtime. So on the side of the cloud, we have public and we have private cloud. In a private cloud, a user has the cloud to themselves. This is in the sense of this is it's not really having the cloud as his own, but a space or a portion of that cloud is for him or that or him or her. Like for his solution, it has a dedicated server for a solution. So private cloud is similar to dedicated server in traditional hosting. Is that okay? The solution has a server to himself. He's not sharing resources with any other person, and he or she can customize and use the resources anywhere they want to use. So the private cloud is defined as a computing service offered either over the internet or a private internet network and only select users instead of the general public. So let's say I work for an organization that has a private cloud and we have a private cloud server. That private cloud server is owned by us, and the management and configuration, everything is done by us. We don't have to go about the public with the public customers don't have access to the cloud. It's just we. So we are the ones that solely handle it. etc. So let's say we have a private cloud supplied by maybe Amazon Web Services. They won't assign any other customers to that cloud since we've already bought it. So that's just how it works. That cloud is solely for us and we can do whatever we want to do with it. In fact, we can also release out resources from there to other customers, but the cloud is owned by us. And most people are going for private cloud because of the security and the flexibility. So on the other hand, public cloud is a cloud service that shares computing services amongst different customers, even though each customer's data and applications running in the cloud remain hidden from other customers. So this public cloud is just like a shared hosting, a shared domain. So you know that not only you is not only you're not the only one using the resources there, other customers too have access to it. Yeah, so that's basically what that is. So this is a brief description of the difference between public cloud and private cloud. So on the left hand side, we can say that public cloud has publicly shared virtualized resources. Like I said, virtualization is technology, and it is one of the technologies behind cloud computing. As for private cloud, privately shared virtualized resources. Public cloud supports multiple customers. Private cloud has a cluster of dedicated customers. So public cloud supports connectivity over the internet. Private cloud supports connectivity over the internet, fiber, and private network like a VPN. So let's say your company has like a private cloud server. You might be able to access those cloud resources only when you're connected to their virtual private network or virtual personal network. This is for security reasons and all of it. So public cloud is suited for less confidential information, while private cloud is suited for secured, confidential, and core systems. So what are the benefits of cloud computing? Cloud computing, one, saves costs. How do I mean? Traditional computing or traditional hosting doesn't save costs because you are paying upfront. But on cloud computing, you are paying for only what you use. Efficiency, when deploying applications, the cloud provides tools that help us. They provide IDEs, they provide security solutions, they provide access management and all those things. So the cloud provides tools that we can use to help us better our application development and software development lifecycle. Accessibility, the cloud is accessible from anywhere as long as you have an internet connection. Flexibility, you can have various virtual machines or virtual servers and you can configure them to work independently or independent of them. So innovation, cloud computing has also is a new field. So there are many innovations that were not available through traditional hosting and opportunities. Cloud computing has made room for um, job roles like DevOps, SysOps, and other specialized roles. So cloud computing has helped a great deal in providing all this. So we move to cloud security. So what is cloud security? Cloud security refers to a broad set of policies, technologies, applications, and controls utilized to protect virtualized IP, data, application services, and the associated infrastructure of cloud computing. Cloud security is of ideal importance. With the increasing number of bad actors and security threats, we have to make sure that our data and information are kept safe and do not fall into the hand of bad actors. Who are bad actors? Bad actors, there are many there are different bad actors. We have hackers, we have script kiddies, we have a bunch of them. So these bad actors, most of them just are just out there to steal information, to bring down applications, just to cause harm to data. And once sensible information are in the hand of these bad actors, it doesn't normally go well with us, and it also spoils our reputation. So cloud security is very, very important, and I'll be explaining the need in the following slides. So we have some elements of cloud security. We have user security, we have device security, we also have network security, we have data center security, and we have content security. I'll be explaining this in detail. Elements of cloud security are just like the what the word elements of cloud security, basically like what makes up cloud security and all that. So one, we have user security. User security generally encompasses three A's, and one is authentication, two is authorization, three is access control. Authentication establishes who the user is in the relation to the organization. Authorization determines what a valid user can access. Access control manages what the user or groups can do within files and folders to which they have access to. So basically, authentication. Let's say you have an application hosted in the cloud, and you have various teams working on the deployment of the application. You have to authenticate them. You have to authorize them. You have to give them specific permissions on what they can do. You have to use a role of least privilege. Not everybody should be able to access all resources, and access control. You have to manage what the users or groups can do with these specific files. You should be able to choose or select people who can edit files, who can do certain things, who can change things in the cloud. So that's about user security. We have device security. So device security focuses on all the different endpoints in the organization's environments, which is where the content is actually consumed and created. Ideally, device security starts with the mobile device management (MDM) that identifies all the mobile devices that connect to an organization's network and apply basic corporate policies and data leakage protections. So this is very, very important. Management or the IT security or IT security person in the organization should have strict policies of users who connect to the network or to the service or resources of the organization using their mobile devices. So IT should remotely wipe lost or stolen devices to better protect data on compromised devices. Because if a client or customer, or let's say an employee's device is 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 hacked or is penetrated, and he or she connects to the network, the hacker can access the network resources and can bring down services. So there should be strict policies. There should be strict policies. There should be measures in place so that this doesn't happen. Because once one node or host is compromised, it is easy for the hacker or bad actor to get access to other confidential files. Yes, so IT should remotely wipe lost or stolen devices to better protect data on compromised devices. Basically, before any device should be allowed to connect to an organization's environment, some security checks should be put in place on the network and some policies should be in place, basically. So that's device security. The next one is, okay, so this is device security. You can see various devices. I can see tabs, I can see some laptops, I can see mobile phones. So you can see that this is kind of interconnected. And once something is interconnected in a network, data is exchanged. So let's say the guy with the laptop is compromised. The person controlling the or the person that has hacked the laptop can gain access to all over the all other devices because you can say that it's kind of interconnected. So if all these policies are in place, it won't be too hard it will be very hard for any bad actor to have access to company's resources. So this is just like an interconnection, and this is a typical business environment. And most times you won't have more mobile devices. So it's not really easy to keep track of all these devices. But once the policies are in place, I believe everything should go smoothly and to be secure. So we have network security. Data can be intercepted while being transported over the network. I said that network security protects this in-transit traffic from all devices, clients, and even custom applications that are consuming or generating the content to the data center. This is usually accomplished through encryption, such as 256 AES. AES means Advanced Encryption Standard. Is an encryption algorithm. Is a standard encryption algorithm, and basically, encryption means making information not readable or accessible unless it's decrypted. So all traffic on the network should be encrypted using either AES, 256 AES. There are other encryption standards. I know of AES, I know of WPK and all of that, but AES is very strong. So if this is configured properly on the network, cloud security won't be easy to compromise. However, there are other ways that bad actors can get to cloud security, but once all these are in place, it will be easier for cloud process to be secure. So we have the last one, but not the least, of elements of cloud security, which is content security. So content security is basically controlling and ensuring that content, that is data, is protected whenever it leaves the company's file sharing environment. Let's say we have, let's say in a company called XYZ, when everybody comes in the morning, they are required to log in using their credentials, and they can have access to files and groups, etc. Content security is very, very important because if this falls into the wrong hands, a lot of damage can be done. So content security can be achieved through one, implementing timeout mechanisms. So there should be amount of time which a person can be logged in without inactivity. Let's say I log into my computer in the morning when I come. I log into the computer's network and it's idle for about 5 minutes. It should automatically time me out, so I will have to re-authenticate. That's a very good mechanism in ensuring content security. Also have remote wiping. Remote wiping just basically means that if any device or host is compromised, I should be able to clear all the data remotely. The use of encryption mechanisms, like I said before, we have AES, we have WPK, the other encryption mechanisms. Encryption is very, very important. Then we have context locks, i.e., preventing editing. An employee should be able to have access to files, but he or she might not be able to edit it. He can only view. So if all these are in place, context security and cloud security won't be an issue. So move on to now our next subtopic, which is cloud security is a shared responsibility. What do we mean? Cloud security as a shared responsibility just simply means that each party has a role to play in ensuring the security of data. How do I mean? Both the users and cloud service providers are responsible for the security. However, if both parties play their role, it results in a highly secure environment. So the user or customer is responsible for application security, and they can do this through one proper authentication, using strong passwords, using keys, public keys, rotation of keys, authorization and identification. The cloud service provider, maybe Google Cloud, Amazon, Kamatera, IBM, is responsible for platform security. So, and how do they do this? By management of the physical machines, bringing out patches for the operating systems, securing the data centers, ensuring tools that help customers, etc. So both parties are responsible for infrastructure security. Here, the service provider or cloud service provider provides tools that the user can use to manage their virtual machines, network, and data access needs. So, like I said, the user is responsible for the application security. The service provider is responsible for the platform security, while the user and the cloud service provider are responsible for the infrastructure securities. So, and how is this done? The service provider provides tools that a user can use to secure his or her cloud resources. And most cloud service providers give you this option. Actually, is at quite an expense, but we cannot overemphasize how much security is needed. So that's basically what cloud security as a shared responsibility is. So actions that you can take to secure your cloud hosting. One, you have infrastructure actions, which is configuring load balancing, migrating to a more secure virtual machine instance. You have preventative actions. These are actions that the user takes to prevent breaches before they occur. For example, identity and access management. So I'm going to show you how to, I'm going to quickly show you how to configure identity and access management. I'm going to be using Google Cloud. So I'm going to be sharing my screen now. Can you see my screen?
We
Yes,
can
you can.
slide.
Yes, we see your PowerPoint.
Okay, yeah, I want to show you how you can configure identity and access management on your cloud service.
We're only seeing your PowerPoint slide for now.
Yeah, I know. I'm going to switch over now.
Alright, cool.
Can we see it?
Yeah.
Go to my cloud platform now. Can we see my screen?
Yeah, it was a
No,
Google
not yet.
Cloud platform, but it's just rolling.
Not everyone can see your screen.
Okay, I see Compute Engine.
Okay. So I'm going to just go to the home. Okay, so if you can see my screen, as I navigated to the drop down menu for navigation menu, you can see IAM and admin. Can we see that?
No, not
Can we
yet.
see that?
Some of us can't see it though.
Your screen is just frozen on the computer engine. You may need to stop and reshare again.
How about now?
Yeah, we can.
Okay, so from the navigation menu, there are different services here. There's billing, there's API, there's supports, there's IAM. From the IAM simply means identity and access management. I just go to click the first one, which is IAM. Then from there, I can configure specific rules for people in my organization. Sorry for the delay. My network. Wow.
I think he got kicked out.
Okay. I'll be back shortly. Um, while we wait for him, should I just share some? Okay, he's back already.
I'm very sorry again. I'm very sorry for the delay. I had network issues, but I think I'm okay now. So I want to show you how to set up privileges for customers in an organization using Google Cloud Platform. So if you have a Google Cloud account, all you need to do is just to sign in using your profile, select a project, then by the top left, you click the navigation button, and to bring out a dialog such like a menu. So from there, navigate to IAM and admin, and you click on IAM. So this is the IAM dialog. Can we all see it?
No,
Yeah,
not everyone can see it though.
I can see it.
I can see it too.
I
Okay,
can't see it.
so okay, I have to refresh or go out and come back in. So um you can see permissions for projects. This is my project, and on the left hand side you can see some other tools which are identity and organization. You can see policy troubleshooter, you can see organization policies, you can see quotas, service accounts, and etc. So it's from this panel, this IAM panel, that I select or assign roles to anybody in my organization. So all I need to do is I simply click on add, and because it's owned by Google, you have to have either a G Suite account, you have to have a G Suite, either a G Suite account or a normal Gmail account. Then I just enter the email address. So let me say XYZ gmail.com. Then I select a row.
Sorry, Chibuzor, your screen is frozen on the
It's frozen. It's frozen again. Wow. It's okay now. Hello? Can you see my screen?
It's loading. Give
I
it a
can't
moment.
see.
It's loading. Give it a moment. Yeah, still not.
Are we good now? Can we see it?
Not yet.
Please, for those of you that just joined, please go to the chat section and register your names, please. Thank you.
How about now? Can you see my screen?
We can see your screen now.
Yeah,
Okay.
we can see your screen.
So all the thing we need to do to add the role is just to click add and you enter the email address of the person you want to add. Let me see. Chibuzor. Bincom email.com. After adding the email of the person, then you select the role. So there are many roles. There's many roles. We'll just use one that is quite common. Let me use Cloud SQL. So this is simply an SQL server hosted in the cloud instead of local one that you download on localhost. Cloud SQL. Okay, so this is it. I select Cloud SQL. Then you can see the various options you can give each of the person. You can give the person admin, which means that he has full rights to full control of Cloud SQL resources. You can give the person Cloud SQL clients, which the permission, the privileges houses connectivity, access to Cloud SQL instances, Cloud SQL editor, which is full control of existing Cloud SQL instances, Cloud SQL viewer, which is read only. So let me say I want to give this person cloud admin. I just select cloud admin and save. And you see the policy set up immediately. So in an enterprise firm, the system administrator will have access to this portal and he or she will assign roles based on what you want to do. So let's say you are a debugger or programmer. All I need to do to enable you to have access to my resources is to add you and give you specific rights. So if you're having issues with your policy, you can go to policy troubleshooter and to help you to give or add appropriate resources. So that's just basically it. So on to our next, the last but not the least is the first one is infrastructure actions, which is like configuring load balancing, migrating to a more secure VM instance. The second one is preventative actions, which is, for example, what I just showed you, how to set identity and access management, policies and rules. The last one is forensic actions. So these are steps to take to track down breaches, detect malicious activity, and stop them before they occur. For example, logging and monitoring. So in the GCP portal, there's a tool that's the GCP provides for us, and it's called security, the GCP Security Center. So there you can scan your instances, you can look for threats, you can look at logs. So this is just a screenshot of what the Cloud Security Command Center looks like. So on the left-hand side, you can see threat detectors, vulnerability detectors, cloud phishing protection, VM patching, access transparency, identity-aware proxy, cryptographic keys, VPC service controls, binary authorization, access content management, and security scanner. So with this tool, GCP has provided you with things to actually secure your cloud. All you need to do is to navigate there, and you can do whatever you want to do. You can scan your servers, you can set up threat detectors to detect malicious traffic on your servers and etc. So this is just a screenshot of what the Security Command Center looks like. I was trying to play it in the video earlier, but had some technical issues. So with that said, I'll pass the microphone on to our second speaker, Mr. Bade Adesemowo, to take over to enlighten us more. Thank you very much.
Thank you, Chibuzor.
Question.
So what we wanted to do was take all questions together right after my presentation. Would you mind waiting through that? I'm not sure who asked about questions now. In the meantime, I'm sharing my screen now. Please let me know when it's my screen.
Yeah, we see a screen.
All right.
So
Someone spoke about question now. Can we wait till after my presentation, or is it something you would like to just ask right away?
yeah, that was me. Well, depending on what we want, the question is related to what the former speaker did just carried
Okay,
out.
maybe you should go ahead, and then please go ahead with your question.
Okay, thanks. So I wanted to know, when adding users, can I add anybody with any email, or should they have to be members of my organization?
Okay, that's a very nice question. So not necessarily. You can add anybody with any Gmail account or G Suite, but the person has to be here. The person has to be a member of your organization. The person has to know what you are dealing with, and you have to have a level of trust, because any policy or rule you assign, the person has some privileges, and there's an extent to what he or she can do. So you should be very careful assigning privileges. You should follow the rule of least privilege when assigning roles. You only assign based on what you want to do. You don't over assign. You don't over assign privileges, so people don't take matters into their hands. Is that okay?
Yeah.
But the person has to have a Gmail.
Second part of that question, which would be, does the user have to be either a Gmail user or a G Suite user? The answer is no for the IAM, but there are some aspects of the cloud or configuration that will require you to have somebody that is a member of your organization. One of that is support, for example. For you to be able to configure someone under your support, they have to be a member of your organization. But aside from that, you can actually assign anybody else on GCP, that is, and also
Thank you very
AWS.
much.
Can you see my screen?
Yeah.
Yes, we can see your screen.
Good afternoon, everybody. My name is Bade Adesemowo. I'm a CTO for Social Lender, amongst many other things. And I'll just be sharing a few things around security as a service. I say that it's an idea that is here to stay. I do apologize that I won't be able to run the presentation. Reason being that I have no way to be able to monitor if you can hear me or not because of bandwidth. And so hopefully we can all see my screen, at least the half of it that has the presentation. And I'll just jump right into it. I will try and be as quick as possible, but there are a few things I wanted to share. Can we all see the door that is on my screen?
Yes, sir.
How useful is this door in the context of how doors are to be used? Is
It's
it
useless.
It's not useful.
The door is useless, most likely. It is very useless, at least not as a door. If it's an art piece or if it's for advertisement, if it's for marketing, yeah, this door may be useful. But in the context of, sorry, I was supposed to switch on my video. But in the context of, sorry. Yeah, I was just switching on my video. Yeah, in the context of using it as a door, as entry, as security, this door is very useless. And that brings me to the point I wanted to make is that a lot of times when we get on a cloud hosting platform or any platform of any nature, there are some assumptions that we make, and some of those assumptions are very untrue. One of those assumptions is the fact that, oh, that platform, AWS, GCP, is going to handle everything that has to do with security, especially when you are paying for support, when you are paying for managed support, for example. But the truth is, it's really not true. It was even those kind of assumptions in the first place, we should never have made them. But those are assumptions that we make. At least in my own early days, I made those assumptions. This is something that AWS always talks about, and every other cloud security platform as well. The truth is, there's not much they can do about your application because everybody has chosen to focus. Cloud hosting providers have chosen to focus on a key aspect that is required and necessary. And that key aspect is providing the platform, providing those platforms as a service for you. There are some things that they cannot have the expertise to manage. Part of those things would be how your actual application works. So they can provide you with Ubuntu, they can provide you Red Hat, they can provide you with different Linux distro. But in terms of the specific application that you put on top of it, there is nothing that they can do about that except you pay for added services, because their own focus is on this baseline, the compute engine, the storage, the database, the network, and so on, and several other things along that line. Availability zone, disaster recovery, all of those things they will manage for you. In fact, you are paying them to manage those things for you. You are paying them monthly, daily, or whatever type of billing support that you have. What they will not manage for you would be network security, for example. They will have the tools are available, but the way you configure the network security is up to you. Identity and access control, which is part of what Chibuzor was just sharing now, is up to you. You have to configure it in the way that makes sense to you. And one of the things Chibuzor was saying is that what if you decide that you're going to just leave it open and that anybody can access a very important file? What if you decide to share your password, your root password, with the entire internet, and then the robot picks it up? What if you decide to share your security key with people that are malicious and have malicious intent? All of those things cannot be managed for you directly, for at least not from these cloud platforms, because that is not, literally speaking, their focus. Can we all hear me? Just making sure I'm not speaking to myself.
Yes, sir, we can hear you, sir.
Fantastic. And so this is something to bear in mind.
Loud
To
and
see, please be clear. Thank you. Please be clear what is being managed, what is not being managed. Be clear on who is responsible for what across your infrastructure. That has to be very clear. And that brings me to the concept of security as a service. It's pretty new. Of course, we all know that the entire computing world as we know it is just about 40 years old or thereabout. But the idea of security as a service is much newer. Within the last 10 years and within the last 5 years has gained a lot of ground. And the idea of security as a service is to say the same way AWS gives you platform as a service, that you don't have to have your own data center. You don't have to invest in having a data center somewhere that would have power, that would have security, that would have very good internet, and so on, which is what AWS is providing for you across multiple things and different solutions, database server, and all of that. Is it possible to have that same business model for the security of a part of your infrastructure? The truth is, security can never be 100% right? It can never be 100% because there are multiple players and it's a shared responsibility. No matter how hard I try, if I configure a very, very secured password, but then you write it on a table where anybody can have access to it, right? Then that whatever I've tried to do in terms of that security with that password has been compromised. And so it cannot be 100% managed by any single entity or player. You have to look end to end at everybody else, right? But the business model is that app service providers that literally are able to provide security as a service. The different aspects of what you need to do as security, they're able to provide it as a service and integrate it into your business, integrate it into the organization, integrate it in such a way that the organization is able to look at all the different layers of what exists, what they are using, what is critical, what is important, and what may not be, and then make sure that each one of them are secured as necessary. I've highlighted a few things. I mean, this is from Wikipedia in terms of the definition of security as a service. I highlighted a few things I just wanted to touch on very briefly because of our time. One of them is penetration testing. Pen testing is something that we would do in terms of application. If you are deploying an application, whether to the cloud or on premise or even on your own local server, right? If it is an application that is in production, penetration testing is something that you should have done, not once, but regularly. As long as there are new upgrades and new updates to that application, those kinds of things are required. Now, can you have a service that ensures that that is happening round the clock, such that whenever there's a challenge, whenever there's something that comes out at you, that thing can be flagged to you so that it can be fixed? We know that there are white hat hackers and there are black hat hackers, and we know their difference, right? Can you have white hat hackers working for you that can bring those kinds of things to your attention? Some of these things an automated tool can find out. Things like SQL injection, and some of those things from an application layer. And things like vulnerability, like if your security key is exposed on the internet, if you're exposing a drive or an S3 bucket that you shouldn't be, and so on. Some of those things can be done automatically, but there are some things that may not be automated as well, because there are several ways you can skin a rat, right? And those different ways you can skin a rat, you may want to have someone that is able to focus on it. Specialization, people say that specialization is one of the things that has changed us as human beings. The fact that one person can decide that they want to specialize as a doctor, right? And they spend 5 years, 6 years, maybe 10 years in school specializing, right? And then in some cases, they spend 6 years in school. Then when you want to specialize again as an ophthalmologist, right, you then need to spend a couple of more years. If you want to then become a consultant, you need to do a lot more study. And then I discovered that for this our eye, they have consultants that focus on different parts of it, the iris and so on. It's the same thing that we're talking about here, to say that people can specialize in different things, and it's something we may want to think about. Years ago, when there was a debate, there's no longer a debate about whether or not, and that's something I was going to share. There's no longer a debate now on whether or not cloud hosting is here to stay. But 5 years ago, 10 years ago, 15 years ago, when I got into this industry, it was a major debate about the question of should you own your own data center or should you go into the cloud and all of that. There are things that prevent that today. I know I digressed a bit, but I'll come back to the point I was trying to make. there are things that prevent organizations, larger ones, from being on the cloud today. One of them is regulation, but even those regulations themselves are changing over time. Regulation of government saying, oh, you cannot have your data outside the country. And so it means that the provider, or outside the continent in some cases, it means the provider has to build data centers in those countries and all of that. So for example, AWS has a data center in South Africa that was built about 4 years ago or thereabout, and all of them are also bringing stuff to Africa to deal with the regulation problem. I digress there. But this is a report I found when I was doing a bit of research for, now my system is frozen, okay. This is a report I found when I was doing a bit of research for this online, and something that I found that was very interesting, I was trying to show, but something I found that was very interesting is that 100% of, I had that page open and I'm so sorry, it was right on my screen earlier, and so what it said was that 100% of, I'll find it now, give me a moment. Can you hear me clearly though? There you are.
Yes, we can.
Okay, fantastic. It was talking about the fact that 100% of organizations, so this research was with organizations that had more than 10,000 staff. So 10,000 staff was like a benchmark. Any organization that was going to be surveyed had to have more than 10,000 staff. And of course, it was 100% to say 100% of them were already either on the cloud or moving to the cloud. It wasn't a question anymore. And that, like I mentioned earlier, this was a debate that was very, very intense a couple of years back. But I was talking about specialization to say security as a service could actually be a specialization as well. Because for many organizations, it is almost impossible to be able to have all the security experts that you require. In fact, some organizations do something called bounty, bug bounties. Twitter, Facebook, literally every of the big tech organization have those kinds of bug bounties where they could pay you up to $1 million if you find a specific bug in their infrastructure, in their solution, and so on. Because security is critical, and they realize that no matter how hard you try, you may never be able to find every single security vulnerability that exists in your solution. That's the reason why Windows always have updates. That's the reason why we hear about different vulnerability, 0-day, and so on. And those things have to be fixed. The good news is, with white hat, if your vulnerability finds its way to a white hat person, they will bring it to your attention. They will not use it against you. And in some cases, they may not even expect to be paid. In some cases, they expect to be. Black hat, of course, I mean, they can sell it in the dark web and so on, and they can use that vulnerability until somebody that should know about it may find out in one way or the other. A popular one that happened recently is Twitter being hacked, and there are many people speculating on how that happened. I read something that hasn't been confirmed, but I found it very interesting, and so I'm going to mention it. But remember, I said it has not been confirmed, right? And they said that part of how they were able to get access to Twitter's infrastructure was physical exploits, that they actually drilled a hole into one of Twitter's data center or something like that. Like I said, not confirmed, but it is plausible, right? Because we focus on all sorts of securing all of the hardware, all of the network, and all of those kind of things. But sometimes we forget about even the basics of it. We've seen movies like Mission Impossible. I can't remember which one of the episode it was, where it was a Burj Lorab, and then Ethan Hunt literally dropped down and got into the data center of the hotel for them to be able to move on with what they needed to do. And that physical, who would have thought that anybody would try to do that? Yes, it's fictitious, but that itself is also plausible. And that's something just to say about security generally, and then also security as a service. It's an idea that is here to stay. That's what I believe, right? Outsourcing your security is what we are talking about. It's an idea here to stay, but you cannot outsource 100%. As I mentioned, you have to think about the different aspects, and then maybe it could be first layer, the outer layer outsourced. And then these are some of the things. I spent a little longer than I wanted to, so I'll just jump into the rest of it, and then we can discuss with question and answers. These are some of the aspects of security that we should be conversant with and be aware of, and I do have a checklist towards the end of this presentation. So let me just talk briefly about this aspect. This is someone's model, and I put the link in terms of the source of the different aspects of security you should think about, especially if you are thinking security as a service. First one is real-time monitor, not in any particular order, is real-time enterprise monitoring. And what that means is that on a per second basis, per microsecond basis, everything that you have should be monitored. You need to have an architecture of your entire infrastructure, and you need to be able to say, oh, this is how I am securing each aspect of this infrastructure. And you are monitoring that on a regular basis. Detailed audit and compliance reporting is important, and there are very many security frameworks, some by the US government, some for healthcare, PCI, HIPAA, and so several others that require you, ISO as well, that require you to do security audit on a regular basis, right? Regular could mean monthly, weekly. It depends on who and what your infrastructure is used for. Of course, if it's health data, that's what we, as at today, as a people, we've decided has to have the most security, people's personal data, especially as regards their health. But of course, banking data, financial information, all of those things as well are all important. And they all have their different levels of how you should secure it. Executing remedial action, when you find something wrong, you need to be able to recommend to say, this is what we need to do, depending on how urgent that security risk is. Depending on the urgency of it, you need to also be able to determine that the level of the risk itself and how plausible is it for it to happen. Would someone actually drill a hole in some companies have their data center in Iceland, in Greenland and Iceland, right? Would someone actually try and drill a hole down into the ice and then try and get back into their data center? Is that plausible? Yes. Is that likely? Well, I don't know about that. Even if it were likely, or if there was even a chance of it happening at all, then what do we do to secure that? And it's the same thing with also the software-based ones, the physical-based one. Two-factor authentication, for example, it's a given now, and it's something that everyone should probably have, regardless of what infrastructure you are managing, because the chances of your password being hacked is significantly higher now because we have better computing power now. And so if you are depending on just one level of security, right, you need to think again. The CEO of Twitter, sorry, I'm mentioning Twitter again, his Twitter account was hacked a couple of years back, 2 years back or thereabout. And how did they do it? They got access to his phone, and then an SMS got to his phone, and then that resets his password. Two-factor authentication may have been able to solve that problem. Let me just jump right into, this will be my second to the last slide, and then we'll throw it up for question and answer. And this shows us some of the different security solutions that we should think about. And these are different layers of those security we should think about. For some of us, we may say, hey, this is not as important as this. But the truth is, depending on the data, depending on the infrastructure, depending on what the platform is, depending on who is using your solution, will determine some of these things. European Union, for example, cares so much about their users that there are some things that are required if you're going to be a software provider or a solution provider of any nature, and came up with GDPR. Nigeria has a version of it now, NIPDR or something like that, which is literally a clone of the GDPR policy with a few things localized to Nigeria. The key point is that there are different things you must think about, and there are frameworks to it. There are body of knowledge and knowledge cracks as regards security, but security is everybody's business, and that's the reason why we must think about it. There's security you need for data at rest, meaning that where you store your data, is it encrypted? There's security you need for data in motion. When you are sending data, is it using basic encryption, HTTPS, for example, if it's going to go over a network wire. But what if you are taking it on a flash drive? There are banks today that actually copy things and then have to move it from one data center to the other on a regular basis because the size of the data they have, right, is so large that they cannot literally just copy it over LAN and so on. And so they move physical tapes, right, from one data center to the other. Question is that what happens if that is hacked? That process now, and that hacking now is physical theft of those kind of things. And of course, there are ways in which they manage all of those things. But the key point is that we must think about that security. And I'm saying that security as a service is here to stay. It's the same kind of debate we had a couple of years back. But I'm saying that we should also not depend 100% on whatever security as a service infrastructure or policy or vendor and so on that you have. You need to also pay attention yourself. And that is my own summation for today, that let's make best use of technology. Thank you, everybody.
Okay, thank you very much, Mr. Bade. Okay, now the floor is open for question and answers. So let's bring forward our questions concerning what I've been taught so far. And I know we've learned a lot from our speakers, Mr. Bade, Adesemowo, and Mr. Duru, Chibuzor. Thank you to them for sharing their knowledge and all. So let's do well to bring forward our questions. All right, I can think Chika. So,
Okay,
Chika, you would
yeah.
like to speak? Right.
Okay. Mr. Bada, you made mention of security for data at rest and data in motion. Could you please throw some more light on that, please?
All right. So data at rest, when we say data at rest, we are talking about your storage. So at a basic level, think about the hard disk on your system. That would be data at rest, right? But at a large level, you would have S3 storage devices from Amazon, Google Cloud Storage, and so on, right? There is a requirement for security of that data. You could use
Hello? Are we still up?
Okay, let's hold on for a while. I think it is connection.
Hello, can you hear me?
Yes, we can.
Yeah, so let me just help him. So your question is in data in transit and data at rest, I mean?
Yes, yes.
Yeah, so basically the data at rest is stored data. Basically, any data you have stored somewhere is data at rest. Data in transit is data that is being uploaded and downloaded at the same time, like a connection to a website you are downloading and they're uploading at the same time. So that has to be encrypted. So there's mechanisms in place for data that is stored, like Mr. Bede was saying, encryption. I talked about some encryption algorithms which are free to use. Then data in transit too should be encrypted so you don't get into the wrong hands. So is that okay? That answer your question.
Thanks, thanks.
Okay. Any other question?
Yeah, I have a question for you, Chibuzor.
Okay. Yeah.
Yeah, let's say you want to build a site like Udemy or like any other learning management website where
Okay.
videos are uploaded on daily basis and so many large um, materials are uploaded to that site. So let's
Okay.
say the person who wants to build that site wants to host it. What are the considerations that the person has to take in terms of hosting a site like that? What is he supposed to use? Is he share those things dedicated or cloud?
Okay. Okay. Actually, it all depends on resources, but for an ideal environment for that type of solution would be cloud hosting with a dedicated cloud hosting. Why do I say that? Because in a dedicated cloud hosting environment, like I said before, you have the cloud to yourself. All the resources are used by just you. You won't have any bit of downtime, and you are paying for only what you are using. So if you opt for a traditional, maybe traditional dedicated hosting, yeah, you're going to be paying your cost on expenses is going to be quite large. Yeah, because you're going to be paying upfront. But with the cloud, you're just paying for what you're using. And let's say you said memory management portal. So let's say you just pay for maybe 1 terabyte of disk space. You pay for virtual CPUs, maybe 30 gig, and you pay for dedicated video and all those. So cloud service providers give you all these in just one. So you don't need to start worrying about maintenance costs per month and everything. So cloud server will be the best because yeah, you're just paying upfront for what you use and you can customize it to your own feel. Yeah, a cloud dedicated server.
Okay.
Is that
Thank you
okay?
very much. Yeah, thank you
Yeah,
very much.
you're welcome.
Okay, any other question?
I have
Let's
one.
do well. I mentioned earlier that we should click on the chat icon and put down our names, email address, and phone number. Please, if you've not done so, let's kindly do so.
I believe Chika has a question. Chika Dibia has a question.
Yeah, yes. I wanted to find out, just as Susan was saying earlier, um, I know in the cloud there is what is called infrastructure as a service and then platform as a service.
Yeah.
Yeah.
Now, among these two, referring to the question that was asked earlier, I don't know the name of the person, but I saw HS. Now, imagine a case where you have to build something like that, and which of these is better off? Is it the infrastructure or is it the platform?
All right. So
In terms of okay,
um let me take that, and
okay,
you will be bothered about whether you are using infrastructure as a service or platform as a service at a certain level. So you'll be bothered about that at a level of, let's say, Netflix, for example, right? And so your infrastructure is everything that you use, like um, your servers itself, the storage itself, the VPC, and so on. All of those things will qualify as part of your infrastructure, right? And so when you are renting servers in the cloud, what you are doing is you are getting infrastructure as a service. Platform as a service now takes it one level further. Remember, I said in my slide that there are some things that are going to be managed for you and some things that will not be managed for you. Platform as a service takes it one step further. But then what it does is that it also limits you to some of the things that you can use or not use. So I'll give you an example of something called ELB, Elastic, sorry, ELB is load balancer. I keep mixing them up. Elastic Beanstalk, EBS, right? On on Amazon Web Services, for example, right? That's something like a platform for a service where things like even the OS you use and so on, it's managed for you, right? But for them to be able to manage it for you at that level, what they would do is that they will ensure that you use specifically their own distro, their own distribution version of it, right? And so what that means is you would have to use something like Amazon Linux and so on. And what you have to make sure is that whatever script you are running is compatible with that platform that they are giving to you. So that's the difference of what infrastructure as a service, platform as a service. But I'm not sure it's something to worry about because it depends on what you specifically are trying to deploy or you need. Hope that helps.
Yeah, thanks.
Okay, any other question? If you have any other question, please let's do well to ask. Okay, if there's no other question, um, at this point, I would want to share my screen. We want to do a brief about Bincom Dev Center services. So I want every other person that is sharing their screen, please can you kindly stop now because actually, all right.
Sorry, just a quick correction. I mixed them up. It's actually what I was saying as infrastructure as a service is platform as a service and vice versa. I just checked now, just correcting that.
Okay, as I repeated earlier, please, if you've not dropped our full name, address, and phone number, do so. Still trying. Okay, can you all see my screen? Can you hear me?
Yes, we can hear you and we can see your
Hello?
screen.
Okay, I think I should just start while
We can
the
hear you,
other
Auntie.
people.
Yes.
Welcome to Bincom. This is Bincom, a multi-location based training and technology center for technology resources and technology solution. And Bincom Dev Center is available at various locations. We have Yaba, Lagos, Ibadan, Kano, Kaduna, Ijebu-Igbo, and Warri. And our plan is to be in various other locations as soon as the nearest future. And these are some Bincom Dev Center services. We have the Bincom Academy, which utilizes the Montessori approach in training participants in basic skills needed for then technology ecosystem. It's form of uh, classes, programming classes, and we at Bincom Academy we offer Montessori training in programming classes, graphics, project management, digital marketing class, and so on. And for now, our classes are online, and uh, people interested person register for our classes and attend it online too. Income Tech internship is designed to enable people to at intermediate skill level to gain mastery and expertise over a period of time. Income Tech apprenticeship is an industrial attachment at various skill level to gain experience and on-job training. Income community events and projects, which is what we are doing now, we're doing today, is geared in giving back to the society in the tech ecosystem. The focus is on informing and exposing youth to current technology trends and how to prepare them for future technology wise. Lightspace is a co-working event space and center. Our Lightspace is up for rent. To interested person who need a co-working space, they need a space for conferences, seminars, and events. We have our light space very available, which can take up to 30 to 40 persons conveniently. And yeah, okay. Image of our light space and all. This is just a list of our trainings. I mentioned programming classes. We offer the PHP, both beginners and intermediate class, Python, beginners and intermediate class, mobile app class, project management class, foundation class, which is the web development class, infrastructure class, which is IT system and all, which is a bit of what that's like a whole of the event we had today. Graphics class, digital marketing class, and all. The class fees, the flat rate is 50,000 naira, but discounted prices are available from time to time. And I mentioned now our classes are online, so has its online fee. And we have various meetups coming up. We have the startup school, which is next week. We have the Angular meetup. We have the social lender digital financial service masterclass, the edtech meetup, Bincom ICT, career talk, digital marketing meetup, data science meetup, Laravel, DevOps meetup, and so many other meetups that will be coming up in the nearest future. And the let's do well to register for these events, these meetups and events, and also invite other persons to register too. Okay, thank you very much. Thank you very much for being a part of this event. Also a big thank you to our speakers for um, being available to share such knowledge and all with us. We are really appreciate and so wish them well. Okay, thank you very much all for attending. Have a good evening.
Thank you. Thank you for having us.
Thank you. Thank you for inviting us too.
Have a nice day. Hope to see you next time.
You do.
Thank you.
Thank you. Chisom, you're still sharing your screen.